Hello students, welcome to lesson 13 on trigonometry. I hope you are all doing well. Good. In our previous lesson, we looked at finding the acute angle of a given trig ratio. So we explained the concepts and then we started solving some examples. So we solved example 1 and 2 and then I gave you example 3 as an assignment. I hope you've all done the assignment. Good. So we'll begin our lesson today with solution to the assignment. Now we were to find y to the nearest whole number. So the underlining word is what? Nearest whole number. We're to find y to the nearest whole number if cos 2y degrees equals 0.6157. So we learned that to find the angle, okay, to find the angle, you have to find the cos inverse of the ratio. So to find the angle here, which is 2y, you have to find the cos inverse of the ratio, which is 0.6157. Okay, so when you do that with the help of your calculator, you get the value of cos inverse of 0.6157. And then you'll be able to equate it to the 2y. You solve and then you get the value of y. Good. So now let's look at the presentation. Sorry. Good. So you have cos 2y equals 0.6157. So our 2y will be equal to cos inverse of 0.6157. Cos inverse of 0.6157. So with your calculator, okay, with your calculator, you make sure it is on and it is on the general mode. You find shift cos inverse of 0.6157. Then you close the bracket. Good. So now you punch equal to. Good. So the calculator is giving us 51.99719884. So I told you that it's advisable to leave it to 4 decimal places, as even the original question, the ratio was in 4 decimal places. So it's advisable to leave it to 4 decimal places. So 1, 2, 3, 4. So after the 4th decimal place, you check the next number. If it is 5 or more, you add 1. If it is less than 5, you ignore all this one and then you maintain what you have. So this one, because the 9 is more than 5, we'll add 1 to this one, making 2. So we are going to have 51.9972, right? So our 2y will be equal to 51.9972. 51.9972. Good. So now we want y. So our y will be equal to 51.9972 divided by 2. Okay. So our y is going to be, let's check our calculator again. Good. So on it. So 51.9972 divided by 2. And this will give us 25.9986. So we have 25.9986. 25.9986. But we were told to find y to the nearest whole number. We were told to find y to the nearest whole number. So you don't leave your answer here. You have to finish. Okay? So now the whole number here is what? 25. And then after the decimal point, we have a digit here which is 9. So if this digit is 5 or more, you have to add 1 to this 5. If it is 5 or less, you maintain only the whole number part, which is 25. So because it is 9, we have to add 1 to the 5. So we are going to have our y to be equal to 26. 26. Good. So the value of y is 26. And that is the solution of the assignment. So check it with yours. Where you didn't get it, make sure you do the correction. And also follow how I presented my work. It should flow in that order. Is that okay? Good. So now, there is example 4. You can look at it, put it down, and then you try it. The next time we meet, I will get it from you. Okay? So I'm not going to solve this one. You copy the question and then you try your hands on it so that you build your confidence. Okay, good. So today we'll focus mainly on another topic, a different one from what you've been doing. Okay, and the topic is special right angle triangles. Special right angle triangles. So we'll look at what they are, and we'll also look at why they are called special. Okay, and then we'll look at the relationship between the sides of special right angle triangles. Okay, so let's begin our lesson. Good. So special right angle triangles. So the definition, we are saying that they are right angle triangles with 30, 60, 90 and 45, 45, 90 as interior angles. So they are right angle triangles with 30, 60, 90 and 45, 45, 90 as interior angles. So this is how they look like. So the presentation of it. So you have your right angle triangle, you have your 90 degrees here, 60 degrees here, 30 degrees here. This one also you have 45 here, 45 here, 90 here. So these two right angle triangles are called special right angle triangles. So these two are called special right angle triangles. Okay, so 30, 60, 90 and 45, 45, 90 right angle triangles are called special right angle triangle. So why are they special? Why are they special? The reason why they are called special is that their sides, okay, have a particular relationship. So there's a particular relationship between the sides of special right angle triangles. So this side and this side and this side, the three sides are related in a way, okay, in a special way to be precise. So this side, the hypotenuse, this side and this side are also related in a way. So because of that relationship, that is why we call 30, 60, 90 and 45, 45, 90 right angle triangles as special. Okay, so now let's look at that relationship that makes them what? Special. Let's look at the relationship. So we have relationships between the sides of special right angle triangles. So this one is the 30, 60, 90 right angle triangle. 30, 60, 90 right angle triangle. Good. So now I have my 30, 60, 90 right angle triangle here. The length of the hypotenuse is not known. This length is also not known, and then this length is also not known. Now this right angle triangle was gotten from an equilateral triangle. Okay, so let's see how we will derive this one. Good. So now if I extend this one, I repeat or reflect this right angle triangle here, it's going to be like this. Okay, and then if I bring this one also down, okay, I'm going to get something like this. Now because this side is a reflection of this side, they will all have the same angle. So this side will also be 60 degrees, and then this side will also be what? 30 degrees. I hope you are following. Good. So this gives us what? an equilateral triangle. This gives us an equilateral triangle. Okay, good. So this side is 60, this side is 60, and this side is also what? 60. So it is what? An equilateral triangle. Now let's look at something. If this side is x, okay, what would this side be from here to here? It will also be x. Good. Now, so x plus x will give us what? 2x. So it means that the length from here to here is what? 2x. Okay, so let's label it A, B, and then C. So AC will be what? 2x. That is the length. Okay, now we know that in equilateral triangle all the sides are what? Are equal. So if this is x, and together is 2x, then it means that the hypotenuse here will also be what? Tell me. 2x. So this side is also 2x. Okay, this side is also 2x, and this side will also be what? Will also be what? 2x. Okay, good. But we need only the 30, 60, 90. So one of it. We don't need all the equilateral triangle. We need only what? One of it. Okay, so good. So looking at the 30, 60, 90 right angle triangle, you realize that if you know the shorter side, which is x, okay, twice the shorter side will give us what? The hypotenuse. I hope you can see that. Good. So the shorter side, if it is x, if you want to find the hypotenuse, okay, you just multiply the shorter side by what? By 2. So this will give us what? 2x. I hope you are getting it. Good. So now it's left with this perpendicular height here. We want to know what the value of this one, or how we are going to get this one. So now that we know this shorter side, we know the hypotenuse, okay, we can use Pythagoras theorem to find what? This side. Okay, so let's do that. Let's do that. So using Pythagoras theorem, let's do that. So now the BC is our hypotenuse. So if we can put D here, the DC will be what? Our opposite in terms of the 30. Then the BD will be what? Our adjacent. Okay, good. So let's go straight from 2x all squared, which is the hypotenuse, is equal to x squared plus, so we use BD squared. Okay, good. So we are looking for BD. So we are going to have 2x squared, okay, 2x all squared minus x squared equals BD squared. So this one will give us 4x squared minus x squared equals what? BD squared. So 4x squared minus x squared will give us what? 3x squared equals what? BD squared. So it means that our BD, okay, will be equal to square root of 3x squared. Okay, and then our BD will be equal to, so with this one, the root 3 we can't find its exact square root, but the x squared we can find its exact square root to get x. So we are now going to have x root 3. X root 3. So it means that the length BD, which is the adjacent to the 30-degree angle here, is x root 3. X root 3. X root 3. So student, I hope you get the concept. Good. So now we have all the three sides of the 30, 60, 90 right angle triangle. If this is x, the hypotenuse will be twice what? the x, so we have 2x. And then we've just seen that to get this adjacent, you have to multiply the shorter side also by what? By root 3. Okay, so there's no need looking for Pythagoras theorem to help you get the sides. Once it is a 30, 60, 90 right angle triangle, if you know the side of the shorter one, the value of the shorter one, you can find the other two without Pythagoras theorem. So if I know this is x, then it means that this is what? 2x, and this is what? Root 3 times what? X, which is x root 3. So if you are using values, if this is 1, this place will be what? 2. Okay, because 2 times 1 is 2, and then this is 1, so it will be what? Will be root 3. So if you are using 1 as the length of the shorter side, then this one will be 1, this one will be 2, this one will be what? Root 3. Okay, good. So let's use specific examples for you to get the concept clear. Good. So let's see. So if I have this right angle triangle, okay, this side is 30, I have my 90 here, and this is 60. Okay, so if this place is 2, what will be the other two sides? If this place is 2, what will be the other two sides? So we've seen that the hypotenuse is twice the shorter side, so 2 times 2 will give us what? 4. And then we also saw that the adjacent is the shorter side times what? Times root 3. So this one will give us 2 root 3. I hope you are following. Good. So if we have another one, the shorter side is 5. This is 30. This is 60. Now, what will be the other two sides? So the hypotenuse is times 2, which is 10. The adjacent is what? The shorter one times root 3, which will give us 5 root 3. I hope you are following. Good. So you do this one for me. Do this one, this one, this one, this one, this one. Then we move on. This one. Okay. So this one, let me make it 9. Yes, 9. 9. So if this is 9, this one is going to be what? 18. And this one will be what? 9 root what? Root 3. 9 root 3. I hope you've gotten the concept. Good. So you should keep this relation in mind. Okay. We'll come to it. Okay. We'll come to it. Good. Good. All right. So that is for the 30, 60, 90. So that is why we are saying that it is a special what? Right angle triangle. Good. Now let's move on to the other one, the relationship between the sides of the special right angle triangle, but this time it's 45, 45, 90. 45, 45, 90. Good. So this one also is gotten from a square. It's gotten from a square. So let me extend this one up, okay, to get the complete square. Good. So we have the square. Now, so if you have a square of any side, and then you draw a diagonal so that you get what? A hypotenuse to get your 45, 45, 90 right angle triangle. Now, if the length of this is x, okay, once it is a square, this side is also going to be what? X. I hope you are with me. Good. This side will also be x, and this side will also what? Be x, because it is what? It is a square. More so, this is right what? Isosceles triangle. So right isosceles triangle. So once it is, we are saying it is isosceles because two of the angles are what? Are equal. So it is a right angle triangle, but it is what? An isosceles what? Right angle triangle. So if this is 45, this will be 45, and this side will be the same as what? This side. So now we have the other two sides. How then can we find the hypotenuse? How can we find the hypotenuse? So using Pythagoras theorem, we can find the hypotenuse. So let's see. So from h squared is equal to x squared plus x squared. Okay, our h squared will be equal to what? X squared plus x squared will give us what? 2x squared. Okay, so our h will be equal to square root of 2x squared. Okay, square root of 2x squared. So our h will be equal to what? We can find the square root of x squared exactly, but we can't find that of square root 2 what exactly. So we are going to have x root what? Root 2. X root 2. So our h, which is the hypotenuse, is what? X root 2. So we have here x root 2. X root 2. Good. So this is also the relationship between the sides of what? Of a 45, 45, 90 right angle triangle. Okay, 45, 45, 90 right angle triangle. So it means that if you know the other two sides, okay, to get the hypotenuse, you have to multiply the other side by what? By root 2. As simple as that. So what if you know this one? So if you know the hypotenuse also and you want the other side, okay, you have to divide by what? By root 2. Straightforward. Very simple. So you don't need Pythagoras theorem to know the length of sides. Okay, the relationship exists between them already. So once this is x, this side will also be x because it is what? An isosceles triangle. And to find the hypotenuse, you just multiply the x by root 2. That's all. Okay, so that is what makes it what? Special. So you don't need Pythagoras theorem to get the sides. The sides already have what? A relationship. I hope it is clear. Good. So let's look at specific examples of this one, then we understand. Good. So if I have, let me use this one. I have this. So this is 90, 45, 45. Okay. If this is 2, it means that this will also be what? Be 2. And this side will be what? The smaller times root 2. So you are going to have 2 root what? Root 2. As simple as that. If I have this one, okay, this is 45. This is also 45. If this is 1, this side will also be what? Be 1. And this side will be what? 1 times root 2, which is what? Root 2. You see? Simple as that. Good. Last one. Do this one for me. So 90, 45, 45. And this is 5. This is 5. So this side will be 5. This side will be what? 5. Root 2. As simple as that. Last one. Last one. Last one. Now, if the side is 9 root 2, find the others. Find the others. So this is 45. This is 45. Good. So we'll get this one by dividing the hypotenuse by what? By root 2. So this one will give us 9. This one will give us 9. Right. So students, this is where we'll end our lesson today. Now, just go over it if you didn't get it. Okay, take your time, watch the video, go over it, and you get it. We're going to apply this one in the next lesson. So make sure you get the concepts, and then when we meet next time, you follow me correctly. Okay, good. So till we meet again, revise, read ahead. Bye.